I have a whole new topic to discuss. Just because that guest speaker's coming in, I'm going to make sure it's all opened up. Is there anything over here?
It's right there.
I have to confess, you guys, it looks like this might be a prime example of committing to a U-sub. I'm sorry, I misspoke. This looks like it would be a prime example for committing a trigonometric substitution. It's just that in this one example, I'm nervous. I'm nervous in the sense that there might be an easier approach, because unlike the questions in the homework last night, for which we committed to those trigonometric substitutions, I think this trinomial downstairs is nicely factorable. And since it's nicely factorable, let's do just that, let's factor it. I think this gives me 1 over the product of these two things. Do you guys agree? Just with our basic mathy skills. Now listen to my choice of words carefully. I'm going to try to motivate you into a whole new technique for integrals. What if I had the mathematical ability to take this one fraction and separate it into the sum of two of the fractions, whose denominators are x plus 1 and x minus 2. And think about this. Go backwards. How do you add fractions? You find a common denominator, you write it as a single fraction. I'm just undoing the addition of fractions. And because this is a proper rational expression, meaning the degree upstairs is strictly less than downstairs, then I think necessarily that means that this numerator will have degree less than this one, this numerator will have degree less than this one. But if that's the case, then since these denominators are degree 1, what must the numerator be in terms of degrees? Just 0 as a degree, which means they're just constants. Can I make them up out of thin air? Now, if I were to be able to find two such constants A and B, I want a yes or no answer. Is your life a 100% absolute piece of cake?
Yes.
Yeah, it is. You wouldn't hesitate. You'd give me the answer, wouldn't you? You'd say, A natural log of this, well, in absolute values, plus B times natural log of this in absolute values. Wouldn't that be nice? So maybe you and I can take a break, pull out a nifty piece of scratch paper, declare what the heck that fraction is that we started with, and simply declare that we could break this up into the sum of two fractions whose denominators are such. Of course, you guys be a little careful with this. This really doesn't work unless I really have an improper, excuse me, I misspoke. It only works if I have a proper rational expression, and it's proper because the degree upstairs is less than downstairs. Now, I guess it's my mathematical responsibility to find values for A and B. So what I will do is I will simply get rid of fractions. I'll clear fractions. I'll multiply both sides by the product of these two bases, and here's what I get. And in clearing fractions, or excuse me, clearing parentheses, I guess I get A plus B times x, plus negative 2A plus B is my constant. And then equating coefficients. I guess that means the coefficient of x on the left-hand side is equal to the coefficient of x on the right-hand side.
Can you go back just
Yes.
a little bit?
Yes.
How did you get from those, or step 1 to step 2?
I skipped too much.
Okay.
So I just expanded out. An ax plus bx minus 2a plus b.
Okay.
And I just simply factored out the x in the first grouping. And just magically put parentheses around the last two because I can. I shouldn't use that word magic. Yes?
How do you get a plus b equals 0? See the 1?
Well, actually, this is a polynomial expression. And so I think if one polynomial is equal to another, then their coefficients have to be the same. And I think on the left-hand side, I've got an x term, it's just understood as coefficient 0. So I think the coefficient of x on the left-hand side has to be the coefficient of x on the right-hand side,
Oh,
or vice versa. And same with the constants. Now, I think I also have a negative 2a plus b is equal to 1, so here we go. We can do this. Write a single augmented matrix and use did I talk
Kramer's
about
rule?
classroom? I said an augmented matrix.
Gaussian
Gauss-Jordan elimination.
elimination.
Or I can set up a single matrix equation using inverse matrices. You guys remember all this stuff, right?
Yes.
Or, like you said, Randall, looking at determinants, I can go ahead and use Kramer's rule. Well, actually, this is 2 by 2. Maybe I don't have to go through all that garbage. Maybe I can use MapD. Maybe I could just use the elimination method like it did back in high school algebra. Or maybe even the substitution method. Or how about, in this case, how about none of them? I'm too tired. I didn't see anything wrong. I just think it's way too much work. So can I show you how I avoid everything? I come back way over here and say the heck with all this garbage. Notice what would happen if I made a number up out of thin air. It just happens to be the 0 of this linear factor. What would happen if I allowed x to be equal to positive 2? Does this whole term drop out? Now I'm left with one equation and only one unknown, namely b. And I think it tells you that 3b is equal to 1. Isn't that a piece of cake? And if you guys allow me to let x be equal to 0 of the other linear factor, that would be negative 1, then I guess that means that this whole term drops out, and I'm left with a times negative 3 equals 1, or a equals negative 1/3. Seriously. Piece of cake. And that suggests that maybe when I come back, whoops, to the left-hand board, I guess I've got values for a and b. They are respectively negative 1/3 and positive 1/3. But doesn't that leave me with this? You guys, that doesn't look very pretty, does it? I said, that doesn't look very pretty, does it?
1/3 times natural log x minus 2 over x plus 1.
Very nice. Now that looks pretty. Could you understand, or excuse me, do you understand the beauty and simplicity behind this approach? In that I took this one nasty, relatively nasty fraction, split up in 2 in such a way that I can just immediately evaluate these integrals because they just give me natural logs. Because again, like any substitution that we had before, not that this is a substitution, but like a substitution, I'm just trying to take a mathematical hammer, ding on what's in the integrand's position, make it look so much easier to just simply anti-differentiate off the top of our heads. Nothing more.
That's only if they're factorable.
You're right, although I confess, you might not be able to factor completely down to linear factors. You might only be able to factor down the quadratic factors. Don't worry, I'll take care of that. So far, so good? Yes.
Can we integrate with any other way, like not the fraction fraction?
You need to avoid fraction decomposition. Well, certainly U sub's not going to work. U sub's not going to work only because I don't have the derivatives downstairs, upstairs, unfortunately. As far as a trigonometric substitution is concerned, could you imagine taking this thing right here, complete the square? I can do this. Let's add our funky little formulas together. Well, to complete the square on x, I'd have to add a positive 1/4 and compensate. I said, jeepers, compensate. But that would just simply give it that. I want a yes or no answer. Would it help if I allowed x minus 1/2 to be equal to secant of beta?
Yes.
Yeah, I think it would. I mean, I can take this approach. I just think, to me, I think this is more work, and if you don't agree with me, don't listen to me. You could have taken that approach. But I gotta confess, my first example is
Too hard.
yeah, really easy. And so maybe subsequent examples where I got a much more complex denominator, that might change things.
Example number 2.
Okay. Okay, by definition, that's no longer an eraser.
Could have written example number 3 out of it.
That's true. Stop laughing.
Synthetic division on the bottom, maybe?
Very nice, I
Yep.
agree. Why?
So you can split it up.
Well, how do you make a decision what you push through the process of that division?
Find your P's and Q's.
Well,
What are P's and Q's? Where'd that come from?
It comes from the technical name that I
Rational
forgot.
root.
Rational root
The rational
theorem,
root
yeah.
theorem, yes. So the rational root theorem is what we're gonna apply here, and yes, along the way, maybe synthetic division to make our life easier.
well, why don't you just factor by cubing? Or factor the...
My apologies, maybe this factor is nice by grouping, let's give it a shot. Are you happy?
No.
Yeah, you see my point, David? Yeah, I try it, and of course that's great, but most polynomial expressions don't factor so nicely by using that technique. Factoring by grouping is so darn specialized, specific. It doesn't occur often. So everybody, I think I blew up my organization. This might take me a few minutes. Can I just start over again over there? And I made this up in my head, but I was doing a lot of multiplication in my head. I don't want to do it again. So can you tell me what I wrote? X cubed plus 2, was it x cubed plus 2x squared?
Yeah.
Plus 2x plus 1? Okay, got it. So everybody, in employing partial fraction decomposition, first things first, pulling out a piece of scratch paper, let's see if you can factor that denominator. Are you ready? Let me see, why not? What do you mean?
Well, you
What?
divide.
What do you mean? Thank you. I shouldn't do any of this. Because I think I can only apply partial fraction decomposition if what's in the integrand's position is a rational expression, but a proper one, where the degree upstairs is strictly less than downstairs. Since it's not, what do you have to do?
You could.
Factors you think cancel.
I just did in my head, nothing does. Well, I have to confess, I mean, there is cancellation, it at least decreases the size of things. I still would do it, but you're right, it doesn't change the fact that I have to come in here and do something else. So, I'm just waiting. I'm unhappy that it's improper.
So we make it
So are
proper.
you. So make it proper by now. How about this?
Cancellation.
How about polynomial long division? Let's you and I pull out our division bar. Put in the dividend's position what's in the numerator's position. Put in the divisor's position what's in the denominator's position. You guys, is this going to do the trick?
Wouldn't it be?
Oh, definitely not. Definitely not. My divisor's got to be what's downstairs. Yes or no, is this going to do the trick?
I don't think so.
I think it is.
Is it?
But I think it's too much work. So if you guys don't mind, can I cheat? Yes, sir.
Why can't you just apply your A's and B's throughout the equation and set those equals to the third plus 2?
Okay, sir, maybe I misspoke that. I don't mean that you can't do it, but if you can do it, that means you're going to break this up into like, I don't know, something like a
That's
mixed.
gonna be like a million different things.
But this could be as big as linear. I'm still gonna break it up. And then with the second fraction, whatever that is, suppose it's gonna be quadratic, then this could be as big as quadratic. I'm still gonna split that one up. I'm saying I'm doubling all the work involved. I'd rather take care of business of translating everything to a proper rational expression first, so I don't have to double my work. That's really why. So everybody, there's nothing wrong with this. Do you want me to finish, just so you see what it looks like?
Yes.
No. One yes. I'll finish. Polynomial division is a game of concentrating on leading terms. So question. The leading term in the divisor's position goes in the leading term in the dividend's position how many times? Once. That being the case, there's a very first term up in the quotient's position. However, 1 times the entire divisor, paying the consequence of my actions, gives me a product of an x cubed plus 2x squared plus 2x plus 1. Subtracting the second from the first, how many x cubes do I have left over?
0.
None, as desired. If I didn't have none, that means I made the wrong choice in that particular term up in the quotient's position. But continuing to subtract, so give me this. Yes or no? Is the degree of this, what's left over, less than the degree of the divisor? Well then, by the division algorithm, I guess I'm done with this division process. And so I maintain that, in the end, I can rewrite this integral of this proper rational expression as a sum of my quotient increased by the ratio of my remainder to my divisor. And check this out, you guys. In that second term's position, beautifully I've got a proper rational expression. I like that. That makes my life a lot easier.
You said there was an easier way?
I would never do this. Can I shorten this up by just using synthetic division?
Please. Yes.
It was a question.
I thought you said no.
Why?
Because
Because the divisor's not clean. It's not of the form x plus or minus a constant. So I can't use synthetic division shortcut. That's a very limited shortcut for polynomial division. It only works in your divisor as of the form x plus or minus a constant. Well, it's not true. I can finagle it to do it in other cases, but for you guys, what you've seen before, that's all I thought we've applied it to. How about this as an alternative? Way too much work. Way too much thinking. I'd rather add a funky looking form of 0. Wouldn't it be nice if that numerator were this? Hold it. The denominator real quick. Wouldn't it be so much nicer if my numerator were exactly what you see downstairs? I mean, that'd be really slick, wouldn't it? Because now this fraction is yeah, right there. It's not legal. I'm the one who actually added a 2x squared to the numerator's position. I'll compensate. I'm the one who added a chooks to my numerator. I'll compensate. I'm the one who added 1 to my numerator. I'll compensate by subtracting 1. Oh, shoot, look at that. That's exactly what I have in the numerator's position with the second fraction. I don't go through all this garbage. It's way too much work. Do you guys agree? Okay.
yes.
Hope you agree.
Can you subtract them because you distributed the negative?
You mean this subtraction right there?
No, the plus 1.
I'm not sure your question. Could you restate that? I'm sorry.
The plus 1?
Here.
To compensate for that 1,
Yes.
you subtract 1.
I subtracted 1 from the 2.
Oh,
And I
gotcha,
got
gotcha,
you.
gotcha.
That's what came from. Or David, do it this way. Just go backward. 1 plus 1. Thank goodness. Just double check my arithmetic. So what's next? What's next? Am I almost done? I don't think I'm even close to being done. I think next I gotta pull out the first of many pieces of scratch paper. In pulling out my first piece of scratch paper, let's see if you and I can't factor that denominator. Since you guys saw a few moments ago it does not factor by grouping, I have to use the rational root theorem. Does everyone remember what the rational root theorem says? No. How about this? The biggest word in mathematics. If this piece right here by the way, I didn't say this, but assume all these coefficients are integers. If this thing right here has a rational sign, then it is of the form P over Q where P divides evenly into the constant term and Q divides evenly into the leading coefficient. Man, what a coincidence. Just this morning, I proved that to my pre-calculus class. Does it sound familiar, please? Come on, Jessica. It really doesn't sound familiar. You guys, I know we're stuck in the middle of a question. I'm not going to raise anything on these two boards, but that's a really big deal. So I promise, like I said, we have somebody come in and speak for just a bit. We'll take a break. I won't erase anything on these two boards because we got a heck of a lot more to do to answer this question. So, everybody, Jessica, is it Jessica Cohn? Yep. Jessica Cohn wants to take over. Actually, how about if I start you off with your